This video will answer questions 4, 5, and 6 from the 2016 BC AP Calculus exam. Now I'll start with question number 4. Question number 4 is a differential equations question, but it's a non-traditional differential equations question. They give us a differential equation. In this case, they give us dy dx equals x squared minus 1/2 y. And I say it's a non-traditional differential equations question because that's not a separable differential equation. All right? That differential equation cannot be separated. So therefore, we cannot use our methodologies to solve that differential equation. In fact, they're never going to ask us in the question itself to solve the differential equation because we don't know how. So as soon as we write this down, we realize what they're going to ask me to do is going to be different than solve because I don't know how to solve that. It's not separable. So we start with part A. Part A says find the second derivative in terms of x and y. So they want us to find the second derivative. To do that, of course, we're going to take the derivative of the first derivative. The derivative of this is going to be 2x minus, now we're differentiating with respect to x, so that's 2x minus, this is going to be 1/2 y prime, right? 1/2 y prime. Now, from there, we're going to have to substitute in y prime. So, because in the instructions it said find the solution in terms of x and y. Well, we do not have it in terms of x and y. We have it in terms of x and y prime. So this is going to be 2x minus 1/2 times, and now for y prime, we'll put in y prime. We get x squared minus 1/2 y. So we're left with 2x minus x squared over 2 plus y over 4 as our solution for the second derivative. Okay, so that was part A. Part B, again, remember, they're not going to ask us to solve this, so they're going to ask us questions about differential equations that we can answer that are not solved. Part B says, let y equal f of x be the particular solution to the given differential equation whose graph passes through the point -2, 8. So we know f of -2 equals 8. Remember, there is a solution to this differential equation. The solution to this differential equation involves a plus c, a constant of integration. So there is a family of solutions to this differential equation. That family being an infinitely large number of solutions because, of course, c is an arbitrary constant. They have, in part B, said, I want to know about that one solution. That one solution, that if we were to graph the family of solutions, right? If we were to graph the family of solutions, of course, there would be an infinite number of graphs on this curve. They want to know about the one solution that goes through the point -2, 8. All right, that's what they're asking. What do we know about that one solution? So it goes on and it says, does the graph of f have a relative min, a relative max, or neither at this point? Justify your answer. So what are we going to do? Well, first we're going to find out if this is even a critical value, right? Is -2, 8 a critical value? And to find out if it's a critical number, we're going to have to first determine whether or not the derivative equals 0 there. So we know what our derivative is. They gave it to us. We'll evaluate this at x equals -2, y equals 8. And what will we get? We'll get x equals -2, so we get -2 squared minus 1/2 times 8. That gives us 4 minus 4, which equals 0. So this is a critical number. Okay, it is a critical number. What does that mean? It means here the derivative is equal to 0. Now, what's happening as we approach this point, right? What's happening as we approach this point? Now, AP exam questions usually fall back onto previously found ideas. They asked us to find the second derivative right here. Well, if this is a relative max, then our graph is going to be concave down at that point. If this is a relative min, our graph is going to be concave up at that point. Well, we can determine the concavity of that point by taking the second derivative and evaluating that at x equals -2, y equals 8. And if we plug that in, we get 2 times -2 minus -2 squared over 2 plus 8 over 4. What do we get here? We get -4, right? This is 4 divided by 2, right? 4 divided by 2. 2 squared, 4 divided by 2. So that's -2 plus 4. So we get -2, which is less than 0, which means we're concave down. So since we're concave down, the point -2, 8, at that point, we have a relative max. Okay, so -2, 8 is a relative max. Part C says, now we're off to another solution, right? Part B said let y equal f of x be a particular solution. In part C, they tell us, hey, in part C, y equals g of x is a particular solution. So it's a different particular solution, and this is the one that goes through the point -1, 2, right? -1, 2. Because they tell us g of -1 equals 2. And then it says find a limit. All right? Now maybe we wouldn't expect to find a limit in the middle of a differential equations problem. So we got the limit as x approaches -1, and the limit they want us to find is g of x minus 2 divided by 3 times x minus 1 squared. But the College Board loves to give us multiple ideas in each question. So in this question, they've asked us, right? They didn't ask us to solve it. We can't solve it. They asked us to find the second derivative. Why did they want us to find the second derivative? Well, they wanted to see if we understood how to find the second derivative. And on top of that, we needed it to discuss relative min and relative max in part B. Now over here, they're asking us to find the limit. Well, what do we get when we plug in -1, right? That's our first go-to move. Obviously, when I plug -1 into g, I get 2, so that's going to give me 2, minus a 2. So that's going to be a 0. Not the end of the world, right? 0 in the numerator is fine. But when I put -1, I think I wrote this down wrong, didn't I? Yeah, this is x plus 1. When I put -1 down here, I get 3 times 0 squared, and we get 0 divided by 0. So we're going to use L'Hopital's rule. Right? We'll use L'Hopital's rule. That gives me the limit as x approaches -1. Now what do I get here? I get g prime, don't I? Because I take the derivative of 2 is 0. Down here I'm going to use the chain rule, so I get 2 times 3, that's 6. I get x plus 1 to the first power. The derivative of what's inside, of course, is 1, and I'm back to here. Now I need to evaluate this. I know g prime. G is equal to y, so g prime is x squared minus 1/2 y. So I know the value of g prime, right? I know the value of g prime because I know when x is -1, y is 2. So what do we get here? We get -1 squared minus 1/2 times 2, right? That's g prime at -1, 2. On the bottom I get 6, I get x, no I don't get x. I get -1 plus 1, And what do we end up with? We end up with 1 minus 1. And on the bottom, we end up with 0 over 0. So we're going to use L'Hopital's rule again. So I've got the limit as x approaches negative 1. I take the derivative of the top. The derivative of the top is the second derivative of g. Well, I know the second derivative of g. Because the second derivative of g is the second derivative of y, and we found the second derivative of y. This is what I was referring to when I said the College Board loves to have their problems roll back. Now, what's the derivative of this going to be? Well, this is really 6x plus 6, so the derivative of that is 6. Okay, we're done with L'Hopital's rule. Now we have to evaluate g double prime at the point negative 1, 2. Well, we can plug that in. So that's 2 times negative 1 minus negative 1 squared over 2 plus 2 over 4. That's our numerator. Our denominator is 6. So if we work this out, we get negative 2. This turns out to be minus a half, right? Negative 1 squared is 1, so that's minus 1 half. This is plus 1 half, all over 6, and we get negative 2 over 6, or negative 1/3. Okay. Part D says, now we're on to our third particular solution, right? Part D says we're going to let y equal h of x. Yet a different particular solution to the given differential equation. And this time we know h of 0 equals negative 2. Sorry, h of 0 equals positive 2. And it says, use Euler's method starting at x equals 0 with 2 steps of equal size to approximate h of 1. All right, so Euler's method, remember, what are we going to do? We want 2 steps of equal size starting at 0 to approximate h of 1. So we need to know h of 1/2, right? We know h of 0, and they want 2 steps of equal size to approximate, so we need h of 1/2. Now, what is h of 1/2 going to be? Well, we know h of 1/2, according to Euler's method, it's going to be approximately equal to h of 0, our starting point, right, plus our width, which is 1/2, times our steepness, which is going to be h prime of 0. So we have h of 0. h of 0 is 2, right? h of 0 is 2. They gave us that. We need 1/2. I need h prime of 0. Now, when I plug in 0, this is h prime. Remember, h is y, y prime is h prime. X is 0, y is 2. So we get 0 squared minus 1/2 times 2. So this is going to be negative 1. Right? 1/2 times 2, 1, negative 1. So what do we get here? We get 2, take away a half, we get 3/2 for h of a half. So what do we get for h of 1, right? Well, we've done our first step, so now we're on our second step of Euler's method. H of 1 is going to be approximately equal to h of 1/2 plus our step width is a half times h prime of 1/2. Leave it to the College Board to give us something with all these 1/2s in it. Now we know h of 1/2 is approximately, right? It's approximately 3 over 2. Then we have plus, we have 1/2. We need h prime of a half. H prime of a half. Well, what are we going to use for h prime of a half? Well, if we take a look at h prime of a half, we would need to plug that back into h prime here, right? So what do we know? We know h prime of 1/2, h prime of 1/2 is going to equal whatever we get when we plug 1/2 back into our derivative. Because remember, this is h prime. H equals y, y prime is h prime. So x is a half, right? X is a half, so we get a half squared. And then we get minus 1/2, and we know the y value there is 3/2. So what do we get here when we're all done with this? Let's see if we can do this. We get 3/2 plus 1/2 times, that's 1/4, That's minus 3/4. 1/4 minus 3/4 is negative 2/4. So that's negative 1/2. So we get 3/2 minus 1/4, or we get 6/4 minus 1/4, we get 5/4. Okay, 5/4. So that's question number 4. Now for question number 5 was also on the AB 2016 exam. So for question number 5, you need to go onto my YouTube channel, open the 2016 AB solutions that address question number 5, and on that video you will hear me welcome you and then show you the answer to your question number 5, and then send you off heading back to this video. Now I don't know that you need to do that right now. You could stick around for question number 6 and then go watch that video after finishing question 6. So I'm not going to do question 5 again on this video. Like I said, it's already done on my 2016 AB exam video. So let me get this cleaned off and we'll jump over, therefore, to question number 6. All right, what are we doing in question 6? I don't know, I haven't seen question 6. So question 6 says the function f has a Taylor series about x equals 1. So that's important for us to realize. It's about x equals 1 that converges to f of x for all x in the interval of convergence. Now they didn't tell us what the interval of convergence is. It's known that f of 1, so this is number 6, we know f of 1 is equal to 1. We know f prime of 1 is equal to negative 1/2. And the nth derivative at 1 is given by. So we have the nth derivative at 1 is given by the following. Negative 1 to the n minus 1 factorial, all over 2 to the n. And this is 4 n greater than or equal to 2. All right? It says write the first 4, this is part A now. Part A, write the first 4 non-zero terms. Okay, the first 4 non-zero terms of the Taylor series for f about x equals 1. So we know then that f of x is going to equal f of 1, right, the 0th derivative, so that's going to be 1, plus, now that's times x minus 1 to the 0, so we've got plus, but it's going to be a minus, because that's minus 1/2, minus 1/2 times x minus 1 to the first power, right, for our first power, divided by, divided by 1, so we don't care about that. So what do we do here now? Our next term is going to be, well, we're going to have to find our next term, right? So we need to know the second derivative at 1, don't we? So we could do that off to the side here, the second derivative at 1. Now for our second derivative, right, n is going to be 2, so it's going to be negative 1, so it's going to be positive. N is 2, so this is 2 minus 1 factorial, that's going to be 1. Factorial, which is 1, and n is 2, so this is going to be 1/4, all right, 1/4, which we all know we're going to want to write, because we're doing a Taylor series here, we're going to write this as 1/2 squared, right, 1/2 squared. Now we're going to need the third derivative as well, so we might as well find that while we're here, right, it's quickest to do the derivatives first. So what do we get? We get negative now, right, negative, because I'm negative 1 to the third. 3 minus 1 is going to be 2 factorial. We could even put a factorial on this if we wanted to. 2 factorial over 2 cubed. Okay, so that's our third derivative. So completing our Taylor series, right? We're only doing the first 4 terms. So what's the second term going to be? Well, it's going to be plus right, plus, and we're going to get 1 over 2 squared, right, 1 over 2 squared, times 2 times x minus 1 to the second. And then our third term, right, is going to be, now this 2 is really 2 factorial, right? There's a 1 factorial here. This is a 2 factorial here. And then what are we going to get in the next term? Well, the next term is going to be, I put a plus, but it's really going to be minus, isn't it? So let's get that off there. It's going to be minus. And then we're going to get 2 factorial over 2 cubed. We're going to have a 3 factorial down there, and we're going to have x minus 1 cubed. Now, they're, you know, it's the College Board. What do they expect me to do? They expect me to clean it up as much as possible. So this is going to be 1 minus 1 half. This is x minus 1 to the first, plus this is going to be 1/8, right? 1/8 x minus 1 squared minus 2 factorial is 2. So that makes that 2 squared times 6. So that's 1 over 24, I believe, if I did my math right there. X minus 1 cubed. Let's just check that. So 3 factorial is 6. That's 2 squared, because we got rid of the 2 up here. So 2 squared is 4. 4 times 6, 24. All right, so there's our solution, right? And it said, write the first 4 non-zero terms and the general term of this. So that would be plus, right? They want to make sure we know the general term. So what's our general term going to be? It's going to be -1, right? -1. Now, if we take a look over here, this is what we're going to get, right? We're going to get -1. We're going to get n minus 1 factorial, right? Now, our third derivative had a 2 cubed, our second derivative had a 2 squared, our first derivative had a 2 to the first, so our nth derivative is going to have a 2 to the n, isn't it? Now, we're going to have our n factorial, and we're going to have x minus 1 to the n. Now, n factorial, n minus 1 factorial, right? We could rewrite this term, and we probably should, right? Oh, I'm sorry. It's -1 to the n. That's n factorial, n minus 1 factorial. So that's just going to leave us a denominator of 2 to the n times n times x minus 1 to the n. So we can write it like that if we want to simplify it. Part B says the Taylor series for f about 1 has a radius of convergence of 2. So our radius of convergence equals 2, right? Find the interval of convergence, show the work that leads to your answer. All right. Well, we know since the radius of convergence equals 2, and it's about x equals 1, right? We're about x equals 1. So if we go 2 here, we get 3. If we go 2 here, we get -1. So right now, we know our interval of convergence for sure is -1 to 3, open on each end. But we have to check the endpoints, don't we? We have to check the endpoints to see if we have a closed interval. And so what we're hoping, of course, is that when we plug in the endpoints, we end up with some kind of nice series that we can work with really quickly. So what about when x equals -1? Right, that's our left-hand endpoint. Well, when x is -1, what are we going to get here? We're going to get -1, take away 1, that's -2, times a -1/2, that's going to give me 1, isn't it? That's going to give me 1. So my first term is going to be 1. My second term is going to be 1. What's my third term going to be? Well, my third term is going to be, well, remember, we're plugging in -1 minus 1, -2, squared 4 times an 8. That's going to be a half, isn't it? What about this term? Well, I've got -1, so that's -1 minus 1, -2, cubed, that's -8. This turns out to be -8. This turns out to be plus 1/3. And then if we keep going, right, if we keep going, the next term is going to be plus 1/4. And so what do we know about this series? Well, we know the harmonic series diverges, and this is even bigger than the harmonic series, so this diverges, right? All right, so our series diverges. So right now, we've eliminated -1, right? We do not converge at -1. What about when x equals 3? Well, again, we're going to have to plug things in and see what happens, right? See what happens. So what do we get? We know we get 1, right? We get 1. Now we're plugging in 3. 3 minus 1 is 1. 3 minus 1 is 1. That's really good. I'm way ahead of my math here. 3 minus 1 is 2. 2 divided by 2 is going to be 1, and I have -1. So I have some hope here, right? I have some hope. We've got at least a sign that's not all positive. What about my next term? When I plug in, remember, I'm plugging in 3. 3 minus 1 is 2. 2 squared is 4. That's 4 over 8, so that's plus 1/2, right? This is looking pretty hopeful. I'm going to plug in 2 here. I'm going to plug in 3. 3 minus 1 is 2. 2 cubed is 8. 8 over 24, this is going to be -1/3, right? -1/3. And we see that we have what appears to be, if we do the next term, we're going to get 1/4. We have the alternating harmonic series here, which we know converges. So we can write out this converges since the alternating harmonic series converges. And adding 1 to that's not going to change the convergence. So they asked us, what is our, right? Let me go back and make sure I answer the question they asked. It says, find the interval of convergence, right? So our interval of convergence is -1 is less than x, is less than or equal to 3, or open at -1, close at 3. Okay? So that's part B to number 6. Now we're going to need to clean this off a little bit. I'm going to leave this up here. Who knows if we're going to need it? I don't want to have to go back and regenerate it. So I'm going to just erase part B, and we'll hope that part C fits down here. So part C says, the Taylor series for f about x equals 1 can be used to represent f of 1.2 as an alternating series. Use the first 3 non-zero terms of the alternating series to approximate f of 1.2. All right. So if we're going to do that, we want the first 3 non-zero terms. So we have 4 terms here. So in part C, they want us to approximate f of 1.2 using our Taylor series up here. So that's going to be 1, right? That's a non-zero term. Minus, this would be 1 point, well, we could write it out. It's going to be 1/2 times 1.2 minus 1 to the first plus 1/8 times 1.2 minus 1 squared, right? That's what we're going to find for our first 3 terms. And what do we get there? We get 1 minus, this is going to be 0.5. Let's just do it as fractions. I was going to change it into decimals, but then I saw the 0.8 and, the 1/8, and it's going to be easier to say fractions. So what do we have here? We have 1/2, right? And then we have 0.2. 0.2 is 1/5. And then we have plus 1/8. And here we have 0.2, right? 0.2 is 1/5, and we're going to square that, right? And so what do we end up with when we're all done here? We end up with 1 minus 1/10 plus, and now that's 25 times 8, right? 25 times 8 is 200. So what do we get? We get 200 over 200 minus, we got to multiply this by 20, 20 over 200 plus 1 over 200, so that's 181 over 200. All right. I don't have a calculator handy, but I think that's right. So what about part D? Show that the approximation found in part C is within 0.001 of the exact value. All right, so to do this, right, what do we need to do? We need to know, right, that we saw that it was an alternating series, right? That we can see it's alternating up here. It's an alternating series. And what do we know about the error bound for an alternating series, right? We know that the error of an alternating series is less than the next term in that series. So we know our error, right? Our error, which is the real value of f of 1.2 minus our Taylor polynomial approximation of 1.2, right? That's, what do we know? We know that is less than or equal to, right? Sorry, I forgot to equal to the very next term, right? So what's the next term? Well, they told us up here to write 4 terms. 1, 2, 3, 4. And yet down here, they only asked us to use 3 of those. Gee, I wonder why. Because they knew we would need this to do this problem right here. So we know this is less than or equal to the absolute value of -1 over 24 times 1.2 minus 1 cubed. Right? So what do we end up with when we get all done with this? All right, we can do the arithmetic, I guess. It doesn't make any difference. So we get 1 over 24, right? And then we get 0.2, right? 0.2 cubed. So 0.2 cubed is going to be 0.008. So we get whatever that works out to be. Again, I don't have a calculator handy. If we do the arithmetic, right? We can do the arithmetic. 8 goes into 24 3 times. So we get 1 over 3,000. And again, I don't know the decimal approximation for that. So that's number 6. Now again, number 5 is done on the A/B test, the 2016 A/B test. So you'd have to go back to the A/B test to watch number 5. All right, keep working.